What is a clutch? Its functions, parts, and how it works. In a car engine, there is a mechanical device that allows the engine to work at a stationary position. It is called a clutch. The component engages and disengages power transmission, especially from the driving shaft to the driven shaft. In other words, clutches connect and disconnect two rotating shafts, drive shafts or line shafts. In this video, we'll explore what a clutch is, its diagram, function, parts, types, and how it works. What is a car clutch? A clutch is a mechanical device that disconnects an output shaft from a rotating input shaft, acting as a linkage between the engine and transmission in motor vehicles. It allows the engine speed to be determined by the speed of the driven wheels, reducing the need for a clutch. In other words, a clutch is a mechanical device that engages and disengages the power transmission from the driving shaft to the driven shaft. The device features two shafts. One is connected to the engine or power unit, the driving member, while the other shaft provides the power output that does the work. In simpler words, a clutch is used to separate the engine's power from the transmission and engage it whenever needed. Pressing down the clutch pedal disengages the connection, and releasing it allows the power to flow to the transmission and the wheels. The clutch is a crucial component in directing power from the engine to the gearbox, ensuring smooth operation of the vehicle's wheels. In electric drills, the clutch's input shaft is driven by a motor and the output shaft is connected to the drill bit. The clutch allows the drill bit to spin at the same speed as the motor, spin at a lower speed, or remain stationary while the motor is spinning. Functions of clutch. The clutch helps the engine run in a stationary position. It can be used to reduce engine speed. It enables easy changing of gears. Smooth vehicle control is achieved. Parts of a clutch. A car clutch has several key components that work together to perform this task. Below are the main parts of a car clutch. Flywheel. This clutch part is mounted on the crankshaft. It keeps running as long as the engine is working. A friction disc is mounted on the outer side of the flywheel. Friction disc. The friction disc could be single or multiple discs, depending on its application. It is made of material with a high coefficient of friction. The friction disc is mounted on a drive shaft. Pressure plate. The pressure plate features another friction disc on it. This pressure plate is mounted on the spline hub. Spring and release levers. The function of the springs is to move the friction disc back and forth. Clutches use diaphragm springs, and levers help to retract the spring. Types of clutches in a car. Car clutches come in different types, each suited for specific vehicle types, driving styles, and transmission systems. Below are the common types of car clutches. Friction clutch. In this clutch, surfaces attached to the driven and driving shafts create friction that transfers the drive. These surfaces are lined with cork, asbestos, or other fibrous material. Cars with friction clutches need to have the linings replaced periodically. The friction clutch is of two different types, a single plate clutch and a multiple plate clutch. Single clutch plate. The single clutch is the most common and used clutch found on modern light vehicles. It helps transmit torque and power from the engine to the transmission input shaft. It is just on the plate, as the name indicates. Multiple clutch plate. Just as the name states, a multiple clutch plate uses multiple clutches to make frictional contact with the engine's flywheel. This transmits power between the engine shaft and the transmission shaft of the vehicle. The number of friction surfaces determines the capacity of the clutch to transmit torque. Centrifugal clutch. Centrifugal types of clutches use a centrifugal force to engage the clutch, unlike others that work with spring force. The benefit of this clutch is that the driver can easily stop the vehicle in any gear without stalling the engine. The vehicle can be easily started in any gear by pressing the accelerator pedal. The working of a centrifugal clutch is quite different as it consists of weights A pivoted at B. The weights fly off due to the centrifugal force when the engine speed increases. The centrifugal force applied operates the bell crank levels, which press plate C. The movement of plate C presses the spring E, which extremely presses the clutch plate D on the flywheel against the spring G. This engages the clutch. The spring G helps to disengage the clutch at low speeds at about 500 rpm, and the stop H limits the movement of the weights. Semicentrifugal clutch. The semicentrifugal clutch also uses centrifugal force along with a spring force, which helps it in the engaged position. The clutch consists of levers, clutch springs, pressure plate, friction lining, flywheel, and clutch plate. The working of a semicentrifugal clutch also occurs at normal engine speeds. When the power transmission is low, the springs keep the clutch engaged. The weighted levers do not put any pressure on the pressure plate. And at high engine speeds, when the power transmission is high, the weights fly, which allows the levers to exert pressure on the plate. This keeps the clutch firmly engaged. The springs in these types of clutches consist of less stiff springs, which allows the driver not to experience any strain while operating the clutch. Hydraulic clutch. In the working principle of a hydraulic clutch, the oil reservoir pumps oil into the accumulation with the aid of a pump. This pump works together with the engine, and the accumulation is connected to the cylinder through the control valve. The switch mounted on the gear lever is responsible for operating the control valve. The linkage mechanism is what connects the piston to the clutch. Cone clutch. In a cone clutch, the friction surfaces are in conical shape with two surfaces to transmit torque. The engine shaft consists of a female cone and a male cone. The male cone is mounted on the splined clutch shaft, which slides on it. This conical portion has a friction surface. The friction surfaces of the male cone contact those of the female cone due to the force of the spring when the clutch is engaged. However, when the clutch pedal is pressed, the male cone slides towards the spring force, which disengages the clutch. Diaphragm clutch. The diaphragm clutch contains a diaphragm on a conical spring, which produces pressure on the pressure plate for engaging the clutch. The spring used is either a crown or finger type, which is attached to the pressure plate. In this type of clutch, the engine power is transmitted from the crankshaft to the flywheel, which contains a friction lining. The pressure plate is located behind the clutch plate because it applies pressure to it. In diaphragm clutch working, the diaphragm is a conical shape of the spring that allows the outside bearing to move towards the flywheel when pressed. The flywheel pressing the diaphragm spring pushes the pressure plate backward. This allows the pressure on a plate to be restricted, and the clutch will be disengaged. If the clutch pedal is released, the pressure plate and diaphragm spring will come back to their normal positions, and the clutch will get engaged. Electromagnetic clutch. The electromagnetic type of clutch is operated electrically, but the clutch is transmitted mechanically. This clutch has no mechanical linkage to control its engagement, which is why fast and smooth operation occurs. It uses a remote for its operation, allowing the clutch to be operated from a distance. The battery supplies the electrical power, and the clutch flywheel has a winding. The winding allows electricity to pass through it, produces an electromagnetic field, and makes the pressure plate get engaged. It disengages when its power supply is cut off. Dog and spline clutch. The dog and spline types of clutches are used to connect the gear and shaft, or lock and shaft, together. The major parts of the clutch are the dog clutch, which contains the external teeth, and the sliding sleeve, which has the internal teeth. The shafts are designed to rotate one another at the same speed and will never slip. The clutch is said to be engaged when the two shafts are connected. Vacuum clutch. This clutch uses the existing vacuum in the engine manifold to work. The vacuum clutch consists of a reservoir, non-return valve, vacuum cylinder with piston, and solenoid valve. The reservoir is connected to the inlet manifold through a non-return valve. A vacuum cylinder is connected to a reservoir through a solenoid-operated valve. This solenoid receives power from the battery for its work, and the circuit has a switch that is attached to the gear lever. The switch is operated when the driver changes the gear by holding the gear lever. The solenoid energizes and pulls the valve up, which connects one side of the vacuum cylinder to the reservoir. This mechanism opens the passage between the vacuum and the reservoir. Freewheel unit. The freewheel unit clutch is also known as a spring clutch, one-way clutch, or overrunning clutch. Its transmission power is in one direction, just as in bicycle transmission. The freewheel is located behind the gearbox. The main shaft transmits the power from the main shaft to the output shaft, which drives the output shaft when the planetary gears are in overdrive. How a clutch works in a car. The clutch consists of two different plates. One is mounted to the flywheel, and the other moves over the crankshaft. The amount of torque applied determines the amount of axial load that is applied to the friction disc. This is to say, the more the axial load, the more the power transmission, and the less the axial load, the lesser the power transmission. The movable disc, which is splined on the crankshaft, moves back and forth with the aid of the clutch pedal. The load is applied by the pressure plate, which is connected to multiple helical springs or single diaphragm springs. If the clutch pedal is completely pressed, the movable friction disc moves back from the shaft, which disengages from the flywheel. There is no power or torque transmission because the pressure plate is not applying any axial load. This is why the engine can run without moving. If the clutch pedal is completely released, the movable friction disc slides forward on the shaft to the flywheel. This is the engaged condition when the disc touches the flywheel. The amount of clutch pedal actuation also affects the working pressure applied. What is a slipping clutch and its causes? When a clutch improperly engages or disengages the transmission, the car may slip out of gear or struggle to stay in gear when accelerating, known as clutch slipping. This can be caused by poor adjustment, wear and tear, or lack of lubrication. A slipping clutch means it has lost the ability to hold the same amount of torque, causing intermittent sliding when engine torque exceeds its maximum capacity. This issue is most noticeable in third or fourth gear and will worsen over time until the clutch is replaced. In rare cases, a worn clutch may leave the car unable to transmit engine power to the ground, causing it to lose torque while accelerating and becoming difficult to control. Causes of a slipping clutch. Common causes of clutch slipping include the age of the vehicle, lack of routine maintenance, infrequent servicing, and aggressive driving. Over time and with high mileage, clutch wear and tear can lead to power loss in the clutch plate. Factors such as driving in stop-and-go traffic and low fluid levels in the clutch system can also contribute to this issue. If the clutch plate is worn out, it may need to be replaced, and the same goes for a worn clutch release bearing or a broken cable. These problems typically require the expertise of a mechanic familiar with clutch and gearbox operations. Symptoms of a bad and slipping clutch. You will experience the following if your car clutch is slipping: grinding sound, difficulty changing gears, unusually high RPM, intense vibration, a harsh burning smell from the engine, clutch feels soft or spongy when pressed, and stuck clutch pedal. From the gearbox, grinding sounds are coming. Difficulty changing gears when applying or releasing the clutch. When traveling forward or changing gear, the vehicle suddenly judders, jerks, or stutters. As the gear slips out, the RPMs when accelerating are unusually high. Your hand should feel intense vibrations emanating from the gearbox if it is placed on the gear stick. Coming from the gearbox was a strong, burning smell. There should be some resistance when you press down on the clutch pedal, but it seems soft and spongy when you do. When you start going, the clutch pedal may stick or refuse to return to its original position. If you have seen any of the aforementioned symptoms, you should know this is what a slipping clutch feels like, and you should take your vehicle to a reputable neighborhood garage right away or get in touch with a mobile technician. How to fix a slipping clutch. Most slipping clutches are not repairable, but changing driving habits may help. Consulting a mechanic is the best course of action to diagnose and fix the problem. While clutch repair or replacement may seem costly, it's better than getting stuck on the road. If you notice your clutch slipping, it's not a good idea to keep driving, as it could fail at any time. It's recommended to drive carefully and have your clutch checked every 60,000 miles to prevent issues.